So trig is going to be used in two major ways here. You're going to be given basically two sides of a right triangle, and you have to figure out the hypotenuse and the angle like we just did. Or you're given the hypotenuse and the angle, and you have to figure out what the two sides are. In this particular case right here, when we're finding the displacement, if we go back to that problem, and just so it contrasts, the displacement was, I think, 4 meters I hat plus 3 meters j hat. And since I erased it, let's put it back up here. This was rectangular form, as I mentioned earlier. In polar form, this would be the magnitude, 5 meters, and the direction of 36.87 degrees. This is polar form. If I ask for a displacement and I don't specify whether I want polar or rectangular, either one. Take the easier one. That's generally my advice there. Do whichever's easier. All right, let's do one example and then get back to the vocab. And again, there are videos that cover this, so that's why I'm not going into as much detail as I normally would. Let's make this a 65-degree angle and 12 meters. So I start out at my house and I end up 12 meters at an angle of 65 degrees from where I started. My displacement would be 12 meters, 65 degrees. How far to the right, how far up would I need to go to get to the exact same spot? This is known as, we're going to be breaking a vector into its components. Later on, when we get into chapter 4, I'll refer to decomposing a vector. So in essence, from a math point of view, we're taking a vector in polar form and putting it into rectangular form. So first off, I'm going to define my directions, my I hat and j hat. I'm going to say I hat is, no, you know what, let's just make I hat to the right, and let's make j hat down. Because why not? Just to emphasize that it really doesn't matter which way you choose is positive. It'll affect your final answer, but you establish your coordinate system and then work on it. All right, so I have some side here. I'm just going to label this A and B for right now until I know better. And I go to my trig functions there. Now there's a common mnemonic. Which seem to come about somewhere between my taking trig and today. Sine is the opposite side divided by the hypotenuse. Cosine is the adjacent over the hypotenuse, and tangent is opposite over adjacent. I'm given the hypotenuse here, so let's actually write down all three of the major trig functions there. The sine of 65 degrees is the opposite length over the hypotenuse. The cosine of 65 degrees is the adjacent length over the hypotenuse. And then the tangent of 65 degrees is the opposite side length over the adjacent length. If I want to figure out A and B, which one should I start with?
Start with B. Sine and cosine.
Yeah. Start with B, so I think you were suggesting B.
Yeah, you would do sine first.
So solving for B, I got this thing I need to get rid of, so I multiply both sides by 12 meters. And so B is just 12 meters times the sine of 65 degrees. So whatever the sine of 65 is times 12, someone would be kind enough. Somewhere around 10.
10.88 degrees.
10.88 what?
Degrees. Meters.
Yes.
Thank you.
And then A would be 12 meters times the cosine of 65 degrees. If you want to keep doing trig. Of course, at that point, it's a right triangle here. Once you have that side and the hypotenuse, you can also use Pythagorean theorem. So this should be something less than 6, so somewhere around 5.1. It is 5.1? Questions here?
With the polar form, do you not have to write a direction?
This is what I was trying to get across earlier, the fact that we are going to, unless otherwise stated, we will assume that 0 degrees is that way.
All right.
So 36 and positive angles go counterclockwise, and so that's sufficient.
Okay.
If that seems incomplete to you, feel free to always write where the direction of 0 degrees is. But I am going to keep that concession, the fact that we don't have to define that every time.
So polar is the traditional math, like.
Yeah,
okay.
yeah,
Like the unit circle.
yes. Other questions? When I started racing on this side. Oh, we never actually answered the question. Shame on me. So what is the answer in rectangular form?
Just be 5.1 meters I have plus 10.88 meters, J hat.
Close. Don't forget, I decided to be eccentric,
Or negative.
Oh, so negative.
minus. Because I defined down as positive j hat, therefore up is negative. Okay. Any other questions before we get back to what I started? All right, so we have position. Where an object is with respect to the origin. All right, so what we're about to do here is I'm going to establish this as my origin right there. Get rid of all that stuff. So I'm going to establish that as my origin, and just because we need to have some convention, I'm going to say to the right is positive. So right now, it's a one-dimensional problem, I'm just moving back and forth. So the way this game is played is I'm going to say my position right now is, and the answer is either positive, negative, or 0. So right now my position is
0.
all right. So where am I relative to 0?
Positive.
I'm on the positive side. I'm on this side over here, and I said this side, this direction was positive. All right, let's see if we can get more voices in this time. My position is,
Positive.
my position is,
Positive.
my position is.
0.
All right, in a situation like this, we might get some parallax here. Just, if I'm somewhere around there, just, I'm supposed to be at 0. And my position is?
Negative.
All right, so that's how the game is played. Displacement. Where an object is with respect to starting point. Now, we do have actually two different kinds of displacement, depending on context. As I'm walking to the right here, is my starting point from where I actually started, or is my starting point from just before I moved to here? I mean, if you're walking down the hallway, you could consider a starting point as the door, or you could consider the starting point as where you were just a moment before where you are right now. This is the difference between overall displacement and instantaneous displacement. So there's overall and instantaneous. So for this exercise, typically if I ask for the displacement, this is the default. If I want instantaneous displacement, I will use the term instantaneous. So overall is what I mean when I just say displacement. And for the sake of this exercise, I'm going to make this my starting point. So right now, my position is,
Positive.
my displacement,
0.
0.
my position,
Positive.
my displacement.
Positive.
There seem to be
Positive.
fewer voices on that one. You know, as long as you get there. Is my displacement positive?
Yes.
Yeah.
You feeling confident?
Yeah.
Yes.
Good. My position,
Positive.
my displacement,
Negative.
position,
Negative.
displacement?
Negative.
Okay. Anyone need some clarification before we make it more complicated?
Just,
So,
oh, sorry.
You got it
The,
first.
Sarah, then Dylan.
The difference between origin and starting point is that origin, this doesn't really have to do what you just talked about, but origin doesn't change, starting point can change?
Yes,
Okay,
typically, the fact that I have them as different right now is just to emphasize the meanings of the words.
okay,
Typically in a physics problem, you make the origin and the starting point the same,
Okay.
and life becomes simpler. But there are times in which it doesn't quite work as nicely that way.
okay.
As you get farther and farther into physics, remember that physics was developed before computers. And so a lot of time is spent trying to find, I need a coordinate system that makes the math as simple as possible. And so that, in essence, is where we're heading. Other questions before I make it more complicated?
so the instantaneous is where you were previous to the top?
Yes.
Okay.
Yeah. So as I'm walking here, so I just took a step, my instantaneous displacement would be negative because I was just there and I moved this way, but my overall displacement is positive still. And then the scalar term over here was distance. All right. Next level. Velocity. And the scalar equivalent, speed. Your car has a speedometer. It doesn't care about direction. It's telling you the speed. Velocity, though, does care. So how fast and in what direction? An object is going. Now we have two different types, and one's going to be default. So velocity, The default is instantaneous. That's my default. And the other one is average. So if I want average velocity, I will specify average. If I just say what's the velocity, I'm talking about instantaneous. So if I'm starting here, so let's say this is Columbia, South Carolina. And we have Winston-Salem here. We'll assume it's just due north. That's about 200 miles. So let's just assume that's 200 miles. Oops. Miles. I start here, I travel up to there, and there's not a straight road, so you have to take, and then there's rest stops and so forth, and eventually you end up in Winston-Salem. So I looked at the odometer of my car before I left. I looked at my odometer when I get there, and my odometer says that I traveled 500 miles, and it took me 10 hours. My average speed, well, average speed is just the distance I traveled divided by time. So what's my average speed? There we go. I didn't hear units before. 50 miles per hour. Distance divided by time. What is my average velocity? Well, average velocity is overall displacement divided by time. So what's my average? So this formula-wise, total displacement over time. So what's my displacement? I've stunned you. Sorry, didn't mean to. What is my displacement when I travel from Columbia to Winston-Salem in my simplified model? How'd you get 20?
The displacement's 200 divided by time is 10 hours.
All right. You answered a different question,
No.
and you left something off. So, all right, you're almost there. What is the displacement?
Is 200 miles.
Someone else want to help him out?
Oh,
It's 200 is what I'm doing here.
Oh,
Or are you getting 300 from 500 minus 200?
yeah.
Oh,
North?
yeah, just as the crow flies, and that's the piece you were missing. So my displacement is 200 miles north, divided by the amount of time it took, 10 hours. So now what is my average velocity?
20 miles an hour north.
Yep, there we go. The whole thing, 20 miles per hour north. So my average speed is different than my average velocity. Quickly do the Usain Bolt bit. Or whoever's the fastest now. I'm still going to assume everyone, you know who Usain Bolt is?
Yeah.
I think enough nods there, okay. I'm racing Usain Bolt around the track. He zips around the track. We'll just say 400 meters to make life simpler. He does it in 20 seconds. I go around the track, and it takes me 120 seconds. What is Usain Bolt's average velocity? let's start with the easier one. What's his average speed?
10 miles an hour?
How'd you get 10?
20 meters per second.
Thank you. Yeah, 400 divided by 20. Was there, okay. So, so Usain Bolt's average speed, Usain Bolt, 400 meters over 20 seconds, or 20 meters per second. All right. What's his average velocity? Usain Bolt, average velocity. What's his displacement when he finishes?
0.
What direction?
0.
All right, this is known as a zero vector because you have a magnitude of 0 and, I mean, if you've gone 0 meters at an angle of 5 degrees or 0 meters at an angle of 30 degrees, there's no difference there. So you typically just, you can put a vector symbol over the 0. It's called a zero vector. So he got nowhere in 20 seconds. So what's his average velocity?
Meters per second.
All right. When I finish the race, what is my average velocity? You answered a different question. What question is the? All right. So what is? How'd you get 3.3? And what does that tell us? Okay. What is that? What quantity did we just find?
Your speed.
Yes, that was my average speed. So my average speed for 400 over 120, 3.3, I assume repeating, meters per second. What is my average velocity?
0 meters per second.
I'm as fast as Usain Bolt. Matter of fact, I'm faster than Usain Bolt. As long as we look at it right. This is how physics can help you win. Even if no one else recognizes it.